See, we know the remainder theorem and use of it. What is the use of remainder theorem? See, this is the actual division. This is the actual division of polynomials. Means this is the long division of polynomials. Okay, to get the remainder and to get the quotient, we have divided this polynomial by divisor polynomial. Okay, dividend polynomial has been divided by divisor polynomial to get remainder and to get quotient. Okay, and remainder theorem states that without performing this division, we can get the remainder. See, after dividing, remainder comes out to be here is 5, and as remainder is 5, we can get the remainder without performing this actual division using remainder theorem. How? This is the px and this is the gx, and if we equate this gx to 0, okay, see, equating x minus 1 to 0 means getting 0 of this polynomial is what? X equals to 1. X equals to 1, if we put in px, if we are putting x equals to 1 in px, means in place of x we are putting 1. Px is what? 3x to the power 4 minus 4x cube minus 3x minus 1. In place of x we are putting 1. Then 3 into 1 to the power 4 minus 4 into 1 to the power 3 minus 3 into 1 minus 1. Okay, 3 minus 4 minus 3 minus 1. Okay, yes, so this is 3 minus 8, and the sum is minus 5, which is the remainder. Here what we have done, we have not performed actual division. We have simply used the remainder theorem to get the remainder of the division of two polynomials px and gx. Okay, see how we have divided here. Again, with one example, let us understand how to divide, how to perform long division of the polynomial. See, this is the dividend polynomial and this is the divisor polynomial. First term of the dividend is 3x to the power 4 and first term of the divisor is x. Okay, then what we will do? Suppose we don't know the quotient. Okay, we don't know the quotient. What we'll do? We will multiply first term of divisor, which is x, with such a number to get first term of dividend. First term of dividend is 3x to the power 4. So with what number we will, with what variable or with what expression we will divide, we will multiply x to get 3x to the power 4. We'll multiply 3x cube to x or with x to get this x to the power 4, 3x to the power 4. What we have done? We have multiplied x with 3x cube to get 3x to the power 4. Okay, means x multiplied by 3x cube is 3x to the power 4, and we need to multiply all the terms of divisor with 3x cube. So minus 1 into 3x cube is what? Minus 3x cube. Okay, as we have to cancel out the first term of dividend, what we'll do? We'll change the sign. Here this is plus 3x to the power 4, no? So it will become minus 3x to the power 4, and here we have minus 3x cube, so it will be changed as plus 3x cube. Okay, now 3x to the power 4 and minus 3x to the power 4 is cancelled out, and here we'll get 0 and minus 4x cube and plus 3x cube. We need to subtract here, and 4 is the greater and it is having negative sign, so their difference will be minus x cube. Okay, minus x cube. Now, and see, these other terms of the dividend you write as it is. Minus 3x and minus 1 you write down as it is. Okay, now see here what we have. We have a term as x cube with power 3 in the dividend, but we don't have any term with x square in the dividend, so we'll leave space for that. Okay, then what we'll do? First term of dividend is minus x cube, and again divisor is same, divisor is x, so we have to multiply x with such a number to get minus x cube. we have to multiply x with such a number to get minus x cube. So with what expression or number we will or variable we will multiply? We'll multiply x with minus x square. So x multiplied by minus x square will give us minus x cube. Okay, and similarly again we need to multiply other terms of divisor also with this minus x square. So minus 1 into minus x square is plus x square. Okay, x multiplied by minus x square, we have written here minus x square. Why? Because first term of the new dividend is minus x cube. How we'll get minus x cube? We'll get minus x cube when we divide x with minus x square. So x multiplied by minus x square is minus x cube here, and minus 1 multiplied by minus x square is plus x square. Now we have to cancel this out. We have to cancel this out, minus x cube, no? And here we have minus x cube, then we need to change the sign. This will become plus x cube. So minus x cube and plus x cube cancelled out. Here remaining is the 0. Okay, remaining is the 0. And we have plus x square. After changing its sign, plus will be changed to minus, so minus x square. So write minus x square as it is here, and the remaining terms of the dividend you copy down as it is. Minus 3x minus 1 are the other terms. Okay, now the first term of new dividend, this is the new dividend. Again, the first term of the new dividend is x minus x square, and divisor will be the same. Divisor is plus x. Okay, so with what expression or what variable or constant you will multiply x to get minus x square? So we'll multiply x with minus x to get here minus x square. Minus x square and minus x square. Now we have to cancel it out. So in order to cancel it out, we'll change its sign. Minus x square, and after changing its sign it is plus x square. Again it is cancelled out. Now second term of the divisor also is to be multiplied by minus x. So minus 1 into minus x is plus x. Okay, is plus x. So this plus x has to be changed to minus, because we have to change the sign before dividing, before adding or subtracting. So minus 3x and minus x, minus minus, so they will summed up. This is minus 4x and minus 1 as it is. Now this is the new dividend. This is the new dividend. The new dividend is minus 4x minus 1, and first term of new dividend is minus 4x, and first term of the same divisor is x. Now we have to get minus 4x here. So how we'll get minus 4x here? X multiplied by minus 4. We'll write here minus 4. X multiplied by minus 4 is minus 4x. Now minus 4x and minus 4x. Again we need to change the sign. So make it plus 4x. So minus 4x and plus 4x again cancelled out. Remaining is 0 here. Now 1 also is to be multiplied by minus 4. Minus 1 was here as a constant term. Now minus 1 multiplied by minus 4 is, minus multiply minus is plus, no, you know. So it will give us plus 4. Now minus 1 plus 4. But before subtracting or adding we need to change the sign. So plus 4 will become here minus 4. So minus 1 minus 4. Summed up, after summing up, it is minus 5. So minus 5 is the remainder. And one more thing you understand. See, actual dividend was this, and degree of this dividend is 4, and degree of divisor is 1, means degree of divisor is less than degree of dividend. Now next dividend is minus x cube minus 3x minus 1. Again degree is 3, which is greater than degree of divisor. Now next dividend, new dividend, is minus x cube minus 3x minus 1. Degree of this new dividend is 2, and again it is greater than degree of the divisor. Divisor is the same. Okay, now see, our new divisor is minus 4x minus 1, and here degree of this dividend is 1, which is equals to degree of the divisor. Okay, means what I have told you earlier, that degree of the dividend should be always greater than or equal to degree of the divisor. Okay, now here see, degree of the this is the if you consider as the new dividend, 5 as -5 as the new dividend, here there is no variable term. No variable term means x to the power 0, means degree of the variable is, sorry, degree of the dividend is 0. Okay, and here degree of divisor is 1, means degree of divisor is greater here, degree of divisor is greater here than this. Okay, so further we cannot divide it, so we'll consider -5 as the remainder. Okay, and one more thing you understand, degree of the remainder should be always less than the degree of the divisor. Here degree of divisor is 1 and degree of remainder is 0. Okay, now see, first question of exercise 2.3, find the remainder when x cube plus 3x square plus 3x plus 1 is divided by x plus 1. Here we will consider this polynomial as px, means dividend polynomial, and the given polynomial which we have to divide as gx, and gx is equals to x plus 1. So what we'll do, first of all, we will equate the divisor polynomial to 0 to get the value of x. We have equated gx to 0, so x plus 1 equals to 0, means what, x equals to -1. After transposing this plus 1 to RHS, we'll get x equals to -1. Okay, now using remainder theorem, what we will assume, that px means value of polynomial, px at x equals to -1, polynomial, value of polynomial at x equals to -1 is p minus 1, means if you replace x with -1, then value of polynomial at x equals to 1 will be this p minus 1. Okay, and according to the remainder theorem, when px is divided by gx, then the remainder is value of polynomial at the value of variable from which we'll get from gx, and from gx we have got value of variable -1. So when px is divided by gx, then the remainder is p minus 1, this -1 we have got from gx. Okay, now without performing actual division of the two polynomials, we can get the remainder. How? Px at x equals to -1 is p minus 1, and this p minus 1 is the remainder according to remainder theorem. So p minus 1 is equals to, in place of x, -1, so -1 cube plus 3 into -1 square plus 3 into -1 plus 1. -1 cube means -1 into -1 into -1. It will be negative. Okay, and 3 into -1 square, -1 into -1, minus multiplied by minus is +1, positive. So 3 into +1 is +3, and +3 into -1 is -3, and 1 as it is. Now -1 plus 1 cancelled out, +3 -3 cancelled out, so 0. Remainder comes out to be 0. Value of polynomial at x equals to -1, that is p1, is 0. It means what? Remainder is 0. Further, see the fifth bit. Fifth bit is 5 plus 2x is to be divided by the polynomial to get the remainder. Given polynomial to get the remainder. 5 plus 2x, let here gx is 5 plus 2x. Gx is the divisor polynomial, and dividend polynomial is this one, x cube plus 3x square plus 3x plus 1. Okay, now using remainder theorem, what we have to do, we have to get the value of x from gx. So how we'll get the value of x? Equate this gx to 0. 5 plus 2x equals to 0. So 5 plus 2x equals to 0 means we'll transpose this 5 to RHS, it will become, here it is +5, so it will become -5. So 2x equals to -5. Now 2 is in multiplication with x in LHS, so being transferred to RHS, it will become in division with -5. So x is equals to -5 upon 2 is the value of x which we have got from gx. Okay, now value of polynomial means px at x equals to -5 upon 2 will be replacing x with -5 upon 2. Okay, p -5 upon 2 is the value of polynomial at x equals to -5 upon 2. Okay, now so using the remainder theorem, when px is divided by gx, dividend polynomial is divided by divisor polynomial, then remainder of the division is value of polynomial at that value of variable which we get from gx. Okay, and that value of variable which we have got from gx is x equals to minus 5 upon 2. So p minus 5 upon 2 is the remainder, means value of polynomial at x equals to minus 5 upon 2. Now in place of x you put minus 5, so p minus 5 upon 2 is equals to, here it was x cube, so minus 5 upon 2 whole cube, plus 3 into x square, so in place of x minus 5 upon 2 whole square. Now plus 3x means 3 into minus 5 upon 2 plus 1. See, cube of 5 is 125, and if power is odd and the negative number is being cubed or squared, then if power is odd, then your cube will be also odd. Okay, means minus 5 square will be plus 25 and minus 5 cube will be negative, means minus 125, and 2 cube is 8. Okay, 2 to the power 3 is 8, means 2 into 2 into 2 is 8. Now 3 into minus 5 upon 2, here minus 5 whole square, power is even, so it will be positive 25, and 2 into 2 means 2 square is 2 into 2 is 4. Okay, now this is minus 3 into minus 5 upon 2, it is minus 15 upon 2 plus 1. Okay, after simplifying all the fraction, it is minus 25 upon 2 plus 3 into 25 is 75 upon 4, and plus minus 15 upon 2 plus 1 upon 1. Now we have 8, 4, 2 and 1 as a denominators. Okay, so after getting the LCM of the denominators, how we got the LCM? See, 8, 4, 2, 1 were the denominators of all fractions. To get its LCM, see, all the numbers are being divided by 2. They can be divided by 2. So 8 divided by 2 is 4, 4 divided by 2 is 2, and 2 divided by 2 is 1, and 1 as it is. Now again further 4 and 2 are divisible by 2. So 4 divided by 2 is 2, 2 divided by 2 is 1, and 1 as it is. Now again this 2 is divisible by 2, so 2 divided by 2 is 1 as it is. So LCM is 2 into 2 into 2, which is 8. So LCM of the denominators of all the fractions is 8. So write 8 here. Okay, 8 you will write here. Now for the first fraction, you see, for the first fraction 8 divided by 8 is 1. So this 1 will be multiplied by minus 125. So 1 multiplied minus 125 is minus 125. Now for the second fraction, 8 divided by 4, denominator of the second fraction, 8 divided by 4 is 2, and this 2 will be multiplied by 75. So 75 into 2 is 150. Now 8 divided by denominator of third fraction, 8 divided by 2 is 4, means minus 15 will be multiplied by 4. So minus 15 into 4 is minus 60. Now 8 divided by 1, denominator of the fourth fraction, 8 divided by 1 is 8. So this 8 will be multiplied by numerator 1. 8 into 1 is 8. Okay, so minus 125 plus 150 minus 60 plus 8 upon 8 will give us minus 27. So value of polynomial at x equals to minus 5 upon 2 is minus 27 upon 8. Hence the remainder is minus 27. Here I have written only minus 2, so minus 27 upon 8 is the remainder. Now see question number 2. Find the remainder when x cube minus ax square plus 6x minus a is divided by x minus a. Means clearly this is the dividend polynomial and this is the divisor polynomial. Okay, let px is this and gx is this. Gx is divisor polynomial. So 0 of gx means we have to get value of x now. So how will get value of x? By finding 0 of the gx, divisor polynomial. How will find 0 of the polynomial? Equating 0 to x. So x minus a is equals to 0, which will give us x is equals to a. Means value of variable is a. Now at this value of variable we will get remainder. of the division. Now px at x equals to a will be pa. And using remainder theorem, when px is divided by gx, then remainder is value of polynomial at such value of variable which we get from gx, and from gx we have got x equals to 1. So pa will be the remainder of the division of these two polynomials. So in place of x, if you put a to get the remainder, pa is equals to, it was x cube, so a cube minus x ax square, a into a whole square plus 6x means 6a minus a. Okay, minus a was the constant term. So a cube and minus into a minus a into a square is minus a cube. So a cube minus a cube cancelled out, one is positive, one is negative, and here 6a minus a. Okay, these are the like terms. These are the like terms. A is common variable. Okay, so we will have 5a. So value of polynomial at x equals to a is 5a. Hence the remainder is 5a. This we have got using remainder theorem. Okay, this is the solution. This is the solution how we get remainder without performing actual division of the two polynomials. Okay, see the next question. Next question is check whether 7 plus 3x, this you will do by your own, I'll give only hint. Check whether 7 plus 3x is factor of 3x cube plus 7x or not. Assume this polynomial as px and this as gx, means this is the divisor, this is the dividend polynomial, and px is to be divided by gx, px divided by gx. Then how will you get that gx is factor of px or not? If gx divides the px completely and remainder comes out to be 0. Okay, when you are dividing, means without performing actually division, we have division, we have to find remainder using this method, remainder theorem method. Okay, so if remainder comes out to be 0, then gx will be, means this polynomial will be factor of px, and remainder is not 0. If remainder is not equal to 0, then this polynomial gx is not a factor of this polynomial. Okay, now get the remainder. How will you get the remainder? Equate this gx to 0, you will get value of x. X is equals to minus 7 upon 3 you will get. Now put this x equals to minus 7 upon 3 in this polynomial. Okay, and if you are getting the value of polynomial at x equals to minus 7 upon 3 0, then it is factor, and if it is not 0, then gx is not a factor of px. Okay, thank you. This exercise is over. In next video we'll learn factor theorem and factorization of the polynomials, and before that I'll take live classes.